Hello. For this question, you should remember more or less how to prove the addition angle, formulae. So we always use these two right angle triangles where we have an angle A and an angle B, one after another. We are going to use it to prove sine of A plus B and cos of A plus B. But in this case, the proof is almost done. We have to complete and to give some reasons. So a student is trying to prove the sine of A plus B. So he represents or she represents their angles, and this is the proof. Yeah, well, we are missing some bits here. It says explain why PF divided by EF times EF divided by OF in line 4 leads to this in line 5. So line 4. So this bit, why it goes into this one, yeah? So PF divided by EF is cos A. Let's see why PF, EF. So PF, EF is cos A, which means this should be A. So that's where we have to explain, because this is A, but we have to explain why. So you have that this is A. These angles are alternate angles, so this is going to be A, and you can explain that A angle PEQ is A because they are alternate angles. Then this is, if this is A, this angle here, as this is a right angle triangle, is going to be 90 minus A. So this other angle here is 90 minus A. But if you look at this triangle, this is 90, and the whole thing must add up to 180 degrees, yeah? So this angle here, let's call it alpha. Alpha plus my 90 degrees plus my 90 minus A must be 180. And this is already 180, which means that alpha and A must be the same, yeah? So this is going to be A as well. If this is A, cos of A is going to be adjacent, which is PF, divided by hypotenuse, which is EF, yeah? Which is what we have here. And then sine B is EF divided by OF. So EF divided by OE. And we are using, in this case, this triangle, this right angle triangle, yeah? So cos B, no, we need cos, we need sine. Sine B. Sine B is going to be opposite, which is EF, divided by a hypotenuse, which is OF. Yeah, so it's just using that triangle. And you can explain, I'm not going to write everything to not take ages, but you can explain that using triangle OFE, cos B is OE divided by OF. Yeah, and that's just that. So this is the first part. Then, and just to be clear, for the first part, for proving that that cos A is PF divided by EF, you are using this triangle. So you can explain that using triangle EFQ, you can prove that this angle is A. Then you know what the cos and the sine are. Yeah. Then for B, it's a complete line 4 and line 5 to prove the identity. So line 4 and line 5. We have to complete this value here. We know, and it's in the formula booklet, that this bit here is sine A cos B. And I think that's going to help us to work backwards. So this is sine A times cos B. Sine A cos B, yeah. So sine A is DE divided by something. Sine A is opposite, which is DE, divided by hypotenuse, which is EO. So this should be EO or OE. And let's see if that works with this bit here. So OE divided by OF should be cos B. So OE OE divided by OF is cos B. Yeah, so cos B is adjacent divided by hypotenuse. Looking at this triangle here, the B one. So what we have to complete is this bit here. So we have OE and sine A cos B. What else? Explain why the argument used in part A only proves the identity when A and B are acute angles. For this proof, and that's something that you probably should remember, for this proof we are using right angle triangles, which means A and B can only be acute. Yeah, so can only be acute. We cannot have an angle greater than 90 in a triangle, in any right angle triangle. Yeah, right angle triangle. And that's it. That's enough to say that we are using to prove that formula. We are using always right angle triangles, and A and B must be smaller than 90. They have to be acute. And D. Another student claims that replacing B by minus B in the identity for sine A plus B is possible to find sine of A minus B. Assuming the identity is correct for all values of A and B, prove the similar result. So we are just going to find A minus B, substituting B. So we have is sine, so you see the formula here, is sine the first one, cos the second one, plus cos the first one, sine the second. So sine, cos, sine. Yeah, so let's going to do that. I move it. Sine the first one, sine the first one, cos the second one, cos minus B, and then plus cos the first one, sine the second one, sine the second one. Yeah, you can write that this. And now we need to remember what is the relation between cos minus B and cos B, and between sine minus B and sine B. So to change this, we can use the circle. I always like using the circle. I think it's the easiest one, but you can think in a different way. So if I have an angle B, and an angle minus B, so this would be minus B, cos of that angle, cos of minus B, is this one here, and is the same that cos of B. So cos minus B is the same that cos B. And if I think of the same with A, with sine, if I have B again, so if this is B and this is minus B, so the opposite and negative, sine is this one here. So the sine of minus B is the same but negative. So sine minus B is minus sine B. And that's what I'm going to use to substitute in the formula. So this is going to be equal to sine A cos B minus cos A sine B, which is the formula for the sine of A minus B. Yeah, and that's all with this question.